I say just say 77.
Yeah, 77 kiloohms. It just... Okay. 77,000 ohms is what I got for our XC total as well. All right. Our next victim. Okay, so we've got our capacitance total. Get back here. We've got our capacitance total, the I total, and any of the voltages. Which one would you like to solve for next? I total. Okay.
So I total equals volts divided by reactance.
Yes, because that's all the resistance we have in the circuit is just the reactance. When we
have real resistance too, I put that in rectangular.
yes.
Or solve that.
Yep. And that's what we're going to cover probably the second half of today. Okay. That's what I got for currents. Okay, Jameson, we have capacitance total and the voltages. Okay. Correct. That's what I got. While we're solving this guy, what is the key for what our answer needs to be? Smaller than 100. Because it's going to be smaller than our smallest value. So just the same as if these were resistances, if we had 680 ohms, 560 ohms, and 100 ohms of resistance all in parallel, our total value of these guys is going to be smaller than the smallest value. This is our limiting factor. And so our answer comes out to be 75.436 picofarads. Also, once you found your capacitance total, you could go back through and you could verify that our reactance total is correct. You take 1 over 2 pi times the 27.4 kilohertz and the 75.436 picofarads, take the inverse of that, and you end up with 77,000 ohms. Okay, Simon, we've got the voltages left. Which voltage would you like to solve for? Okay, we'll just go with voltage of capacitor 1. Okay, how do we solve for the voltage of capacitor 1? What parameters do we need to know? Okay, think back to Ohm's law. What do we need for voltage? Okay? Voltage is the product of what two measurements?
It's on the board. Look, we're looking for the one, so we come up with one.
Yeah, we're looking for voltage, so we want current and resistance. Yep. And in this case, our resistance is the reactance. It's the opposition to the current. Okay? So for the voltage for capacitor 1, we're going to take the current of capacitor 1 multiplied by the resistance of capacitor 1. So in this aspect, we're still doing the exact same thing. This guy? Okay, so what values are we going to plug into our formula? Yep, the 680 pico. How many? Correct. Okay, and then what was our current? That's our capacitance. Our current's right here, because it's a series circuit. How much? No, our current total is right here. That was the resistance total, was the 77,000. $926. Okay. What values did you type into your calculator? Because your values are close, but you're off on your magnitude. You're a little too small. Okay, so the current going through our capacitor is going to be the 1.91 milliamps. The resistance, 16.2, shouldn't be quite that much. Okay, because we got 1.091 times the 8.542K. So the milli and the K are going to cancel each other out. So if you take the 1.091 times the 8.542, what is that going to give you? Hmm. Let's see. Let me see what you're typing into your calculator.
1.091. And then multiply that by 8.542. No, because they cancel out, so.
Okay.
There you go.
I just keep missing. I just put 1.9 instead
Gotcha,
of
yeah.
1.
Yep.
And then you divide that by 0.707.
So yeah, so to start with, what does that value equal? This gets us the 9.319 volts. Okay? So we're going to start there. Now what we want to do is we want to convert this value from RMS into peak to peak. So our formula for that is voltage peak times 0.707 is equal to the VRMS. Okay? So this time we're given RMS voltage, and we want to convert it over.